OK, another risk that DNS has to worry about are the network attackers that we've discussed. So once again, we'll go through the man-in-the-middle attacker, the on-path attacker, and the off-path attacker, and think about what they can do to try and make a cache poisoning attack happen. So starting with the man-in-the-middle attacker who can read and modify records. Once again, if you're using DNS and there's a man-in-the-middle attacker, you're kind of screwed. There's nothing DNS does to protect against them. There's no cryptography in this scheme. So a man-in-the-middle could just take a DNS response and just edit whatever that response says. And now they're sending a poison record to the resolver. So against man-in-the-middle attackers, DNS has no security whatsoever. Now, what if you're an on-path attacker? Now, this is going to look somewhat familiar from when we discussed TCP attacks. If you're an on-path attacker, you can spoof a response pretending that it's from the name server, even though it's from the attacker. So it's very similar to all of those TCP injections that we saw. The recursive resolver sends a request saying, what's the IP address of eeks.berkeley.edu? The real berkeley.edu name server will be sending a response, but maybe the attacker can send their own malicious response, and they're going to fake the response by pretending like it's coming from the berkeley.edu name server when it's really coming from the attacker. And if their response gets there first, they win the race condition, then the poison record might show up in the recursive resolver's cache. And just like in the TCP attack, the on-path attacker has no guessing that they have to do. Remember that an on-path attacker can read all of the values in the request that the recursive resolver sends. And because they can read all of the values, they can use those values to fill in their spoofed response, and they don't have to guess anything at all. So if you look at a sample DNS packet, this outer header in green is the UDP header. How does the attacker know the source port? That's 53. That's the fixed DNS number. How do they know the destination port, what port the resolver was using? They can just read the request and then put that same number in the response. How do they know the ID? They can read the request, put the same number in the response. So the on-path attacker has nothing. They have to guess. And finally, we have the off-path attacker. Once again, the off-path attacker can try to spoof a response. The recursive resolver makes a request, and the off-path attacker makes a fake spoofed answer that says it's from the name server, but it's really from the attacker. And just like in TCP, because the off-path attacker could not read the request, they have some guessing to do. And one particular field that they have to guess is the ID number. So if this number is generated randomly and the attacker doesn't know this number because they're off path, they need to guess this number right. Remember that this number associates requests with responses. So if you send a request with ID number 29,117, then the response you get back needs to have that same ID number, and the attacker has to guess that. This is why the ID number has to be randomly generated. You might remember a bunch of slides ago we said that this number should be randomly generated for security, and now you know why. It's because by generating this randomly, the off-path attacker has a 1 in 65,000 chance to succeed, and if this was just generated by incrementing a counter or using the current time, then the off-path attacker could spoof responses, and that's not good. So the attacks are kind of similar to TCP. The man in the middle can do whatever they want. There's no security whatsoever. The off-path attacker can spoof a response with no guessing. They just have to win the race condition. And the off-path attacker has to win the race condition and also guess this random ID number correctly. So to prove to you that the ID field really has to be random, here's a little demo of what happens if the ID field is just incremented. You could imagine, and I won't read out all the steps, that an attacker makes a DNS request, and they learn what the value of the counter is. So when it's their turn to spoof somebody else's request, they can just add 1 to the number that they've learned, and they have a very good chance of succeeding. So something like a counter is not going to work. That ID number has to be randomly generated.